So here we got some mixture problems that we want to set up and solve with linear systems. It says how much 1% cortisone cream and how much 5% hydrocortisone cream must be mixed to make 10 ounces of a 2% cream. So the first thing we do is basically just label our bowls. The two things that we're going to be mixing together and putting into one bowl would be the 1%. So I'm just going to label this bowl the 1%. And then the other bowl is the 5%. Those two are going to go together and hopefully mix together to make a 2% hydrocortisone cream. So the variables that we're going to use will represent as X and Y. The total amount when I'm done is supposed to be 10 ounces. All right, so our system comes up to write this as a system. We'll relate the amounts, which is X plus Y. That has to equal a total of 10 ounces. So whatever the bowls are, I'm just going to add these. And then the amount of pure hydrocortisone would be the amount times the percent. So I would take 0.01 times X. That would be the amount from the first bowl, plus 0.05 times Y, and that should give me 0.02 times 10. Right, so the system comes up from the amount of cream, X plus Y equals 10 ounces, but then because of the percentages, it's the percent or the actual amount of hydrocortisone in the cream, and we could set those up to be equal to. So to solve this, the first thing I'm going to do is clear decimals. In the second equation, we're just going to multiply both sides by 100 and rewrite our system. We would get X plus Y equals 10. That's our top equation. And then if we multiply by 100, moving the decimal places over twice, we would get X plus 5Y. And that's supposed to equal 100 times 0.02 would be 2 times 10 or 20. So our system becomes X plus Y, and then equals 10, and then X plus 5Y equals 20. So I'm going to use elimination with this. I'm going to take the top equation and multiply through by -1 and rewrite. So when I rewrite my system, the top equation will become -X. Distributing, I get -Y equals -10. And the bottom equation stays the same, X plus 5Y equals 20. So now I can take and add these. The X terms would be gone, and I'd have -Y and 5Y is 4Y, -10 and 20 is 10. So dividing by 4 or canceling the 4, we would get Y equals 10/4, which is the same as 5/2, or 2.5. So if I substitute this back in the original, we would have X plus, and then the Y is 2.5, and that's supposed to equal 10. So if I subtract 2.5 from both sides, it looks like I get X equals 7.5. So now I want to answer the question, and again, we could come back over here to answer it. So the answer, looking at our mixtures, X was the 1%. So X is 7.5. So we're going to mix 7.5 ounces of the 1% and 2.5 ounces, and that's my Y, which is the 5%. All right, the next question is talking about the cost per pound of these confettis, and I am mixing these together. So again, this is a mixture problem. I want to know if I take and mix these together, the two different types of confetti, would I want is to label what's being mixed with the dollar amount. So this would be $3 per pound, and this one would be $4 per pound. I want to end up with something that's $3.65 per pound. So the variables that I'm going to use are just going to be X and Y, and the total amount when I'm done is going to be 400 pounds. So again, this should be just like any mixture problem. The $3 one we could maybe write as the multicolored, and the $4 a pound was the metallic star. We can kind of keep track, but the system comes up by the total pounds. So when I set up my system to solve, it's going to be just the total pounds of the confetti. So if I add X plus Y, I should get 400 pounds. And then the second equation comes from the cost of each one, or the total cost. So the first bowl, if I had X pounds at $3 a pound, the cost of that would be 3 times X. If I add then the cost of the second one, would be $4 times Y. And that should equal the total cost, which I can get by taking 400 and multiplying by $3.65, or 365. All right, so here is my system. Again, I want to use elimination method, I'm sorry. So I want to take, and I'll get rid of the X terms by multiplying the top by a -3 on both sides, and rewriting the system as a -3X and a -3Y equals -1200. And the bottom equation will just stay the same, 3X plus 4Y equals, and 400 times 300, or 3.65, or $3.65, is 1,460. So now I can just add these equations together to eliminate the X term, and I would have -3Y and 4Y as Y equals -1200, and 1460 would be 260. And I'll just substitute that back in to our original here. The top equation, I have it X plus 260, that's the Y, and that's supposed to equal 400. So if I subtract 260 from both sides, I get X equals 140. All right, so the answer, so if X is 140, X was the multicolored confetti, so I'm going to mix 140 pounds of the multicolored and 260 pounds, and that's my Y, and the Y was the star confetti, or star confetti, excuse me, the metallic star confetti. Geez, I can't say it. Okay, thank you.